Differences between univariate data, bivariate data and multivariate data. Univariate data versus bivariate data versus multivariate data. Univariate data refers to a type of data in which each observation or data point corresponds to a single variable. In other words, it involves the measurement or observation of a single characteristic or attribute for each individual or item in the dataset. Whereas, bivariate data involves two different variables, and the analysis of this type of data focuses on understanding the relationship or association between these two variables. Whereas, multivariate data refers to datasets where each observation or sample point consists of multiple variables or features. Univariate data only summarize single variable at a time, whereas bivariate data only summarize two variables. Whereas multivariate data only summarize more than two variables. The main purpose of univariate data is to describe, whereas the main purpose of bivariate data is to explain, whereas the main purpose of multivariate data is to study the relationship among them. Univariate data does not contain any dependent variable, whereas bivariate data contain only one dependent variable. Whereas multivariate data is similar to bivariate data, but it contains more than two variables. Univariate data does not deal with causes and relationships, whereas bivariate data deal with causes and relationships and analysis is done. Whereas multivariate data does not deal with causes and relationships and analysis is done. Univariate data analysis use frequency distribution and descriptive analysis such as measures of central tendency and dispersion. Whereas bivariate data analysis use correlation because the analysis of two variables are done simultaneously. Whereas multivariate data analysis represent different aspects, characteristics, or measurements related to the observed phenomenon. When dealing with three or more variables, the data is specifically categorized as multivariate. Univariate data results show in bar graph, histogram, pie chart, line graph, box and whisker plot, etc., whereas bivariate data results show in tables where one variable is contingent on the value of other variable, such as correlation matrix, regression analysis or two-sample tests, comparison of means, scattergrams, cross-tabulations, etc. Whereas multivariate data results show in tables such as conditional tables, partial rank order correlation, multiple and partial correlation, multiple and partial regression, path analysis, etc. Sample question of univariate data is, how many of students in the BS physics class are males? Whereas sample question of bivariate data is that, is there a relationship between the number of males in computer programming and their scores in mathematics? Whereas sample question of multivariate data is, what is the impact of inflation, interest rates, oil prices, exports, imports and gold rates on GDP? Example of a univariate data can be height, age, gender, income, etc. Whereas example of bivariate data can be temperature and ice sales in summer vacation, CGPA, gender such as male and female, etc. Whereas example of multivariate data, suppose an advertiser wants to compare the popularity of 4 advertisements on a website link. Then their click rates could be measured for both men and women, and linkage between variable can be examined. Kindly subscribe my YouTube channel Thesis Helper. Thanks for watching.